Hey everyone, my name is Rahul and today we are going to learn about the slope. Okay, so before understanding the slope, we have to understand what is line. So you can see here, there is a definition for line, a simple definition and a definition in context of mathematics. So if you see the simple definition, so line is a straight path, so that extend in both direction without an end. Okay, so like you can say that in the 2D space, a line can have no end. A line can have means end must can be infinite. Okay, so line can have no end. And in terms of mathematics, if you read that, a line on the graph shows how one variable changes in relation to another. So this is little bit tricky. So yeah, let's understand to make it more clear and simple. Okay, so if you see this graph, so this graph represents the study hours versus marks. So if you see the x-axis, so on the x-axis you can see the study hours are plotted. Okay, and on the y-axis you can see the number of marks scored are plotted on the y-axis. So, and there is a line drawn. Okay, so what does this line represents? This line represents the relationship between the study hours and marks scored. Okay, so let's understand the table. Okay, this is the tabular data. So this represents the relationship. So if you see this, understand this table, then you will have a better idea how this line works and what information does it represents. So if you see that study hours is denoted by variable x and the marks code is denoted by variable y. So as the study hour increases, okay, as the study hour increases, the marks code also increases. So the variable y, okay, this variable y is dependent on the study hours. Okay, so this variable y in changes when the study hour changes, and this is a positive relationship. Okay, so when the x variable increases, then y also increases. So, and this relationship is linear. Okay, so you can see that for every extra 1 hour of study, a mark is increases by rate of 10. Okay, so this line is also called a positive linear relationship. So by using this data, okay, by using this data, we have plot this line. So this line give us information about the data, the tabular data. Okay, so this line represents positive linear relationship. Now let's understand what is called a negative linear relationship. So you can see here, there is this graph represents the price versus a quantity in demand. Okay, so let's see the tabular data. So here the x variable and y variable. X variable represent price and the y variable represents quantity demanded. So you can see here, as the x increases, okay, on the x-axis, if the value increases, then on the y-axis the value is decreasing, okay, dropping. So you can see here, as this value is increasing, this value is decreasing. Okay, so the line is coming in downward direction, you can see. So this is called a negative linear relationship. Yeah, so now let us understand the how line is represented in terms of mathematical equation. So you can see here, line is also written by y equal to mx plus b. So you must be thinking that what is m, what is b, what is x. So you know that what is y and what is x. So as we have seen in earlier tabular data, so x represents the value on the x-axis and y represent the value on the y-axis. So this line is a mathematical equation. Okay. So in order to find this line, we have to find value of m and value of b. Okay, so here m represents slope and b represent y-intercept. Now you must be saying that what is y-intercept. So it is a simple, when a line cuts any point on the y-axis, it is called a y-intercept. And here m equal to slope. So what is slope? Then slope is, you can see here, it is represented by delta y and delta x. So delta y means a change, a rate of change on the y-axis, and delta x means rate of change on the x-axis. So it is also called the rise upon run. Now let's study some equations so you can get a better idea how this works. Okay, so let me write this equation. This is a horizontal straight line. This line is a horizontal straight line, and the equation of this line is y equal to 3. So if I want to write this equation in terms of slope intercept form, okay, so the equation of this line, this equation is also called the slope intercept form. Okay, so we can also write this equation as a y equal to 0x plus 3. So here you can see that by understanding the above equation y equal to mx plus b, this one, here m represents 0, the value of m is 0, and the value of b is 3. Okay, so you can see here b equal to 3 means line, as I have tell you earlier, that b equal to y-intercept means the line cuts a point on the y-axis. So here you can see this horizontal line is cutting point 3 on the y-axis. So that's why we can see that b equal to 3. Okay, and here if you see that only there is a change in x, only there is a change in x in the horizontal direction. There is a, so the rate of change is only in the x. So here delta x changes, but there is no change in y. Okay, so delta y equal to 0. So delta y by delta x, okay, equal to 0. So that's why here I have written that m equal to 0. So this horizontal line is also called a zero slope. Okay, now let's come to a vertical line. So this vertical line is represented by the equation x equal to 2. So this equation is totally different from this equation y equal to mx plus b, but in terms of slope we have to understand this, how this vertical line works. Okay, vertical straight line in terms of slope. So if you see this vertical line, if I see this, I can go in downward direction or I can go in upward direction. So the value of y may change. Okay, delta y can change. Okay, but you can see here the value of x is constant. Okay, so delta, there is no change in the delta x. So delta x is delta x equal to 0. Okay, so if I write like this, delta, sorry, delta y, just a moment, let me use the eraser. So delta y by delta x. Okay, so there can be any value, say it is changing at the rate of 5 for example, and delta is x equal to 0. So if you have studied in maths, if anything, any number, okay, upon 0, okay, anything upon 0, any number upon 0 is defined by infinity, but we cannot have an infinite slope. Okay, so we can represent it as a no slope. Okay, or undefined. So it is represented by no slope. Now let's explore other equations. So this is the second graph, and the equation of this line is y equal to x. So let me write in the slope intercept form, y equal to 1x plus 0. So here m equal to 1 and b equal to 0. So as usual, b equal to 0 means the line is cutting at 0 on the y-axis. So you can see here line is passing through the origin. Okay, so that's why b equal to 0. Now you can say that how m equal to 1. So you can see here we will explore that concept rise upon run. Okay, delta y by delta x equal to rise upon run. So if you go like by unit 1, okay, in the y direction, sorry, in the x direction by unit 1, so this is called run. And if I rise upwards, okay, by unit 1, so it is also written by 1 by 1, so it is represented by 1. So here that's why m equal to 1. Coming to another equation, so this line is represented by the equation y equal to x plus 3. Okay, so m equal to 1 and b equal to 3. So you can see here the line is passing through point 3 or the cutting the y-axis on point 3. So that's why b equal to 3. And similarly m equal to 1. So if I run on the x-axis, okay, by unit 1, okay, and if I rise upwards on in upward direction by unit 1, okay, so my delta y by delta x equal to 1, which is my m. So let's explore another line. So this is a line and the equation of this line is represented by y equal to minus 2x plus 3. So this is quite interesting. So that is because there is a negative value of the slope. Okay, so m equal to minus 2 and b equal to 3. Okay, so b equal to 3 you can easily define that the line is cutting y-axis on point 3, that is b equal to 3. But how you can say how can I explore it m equal to minus 2, slope is minus 2. So we know that m equal to delta y by delta x. So change in y and change in x. So if I see here, I am just passing through this point. This is my run, okay, run. This is my change in x by unit 1, okay, and this is my change in y in downward direction, okay, by unit 2, by 2 units, okay. So this is my change in x by 1 and this is my change in y in downward direction by 2, okay. So if there is a change in downward direction, it will be always, that number will be always negative. So that's why we have written that is change in y in downward direction as minus 2 and change in x, so this is represented by 1. So my slope will be minus 2 as we have defined the equation here. Now coming to the last equation, okay, so this equation is represented by y equal to minus 2 by 3x minus 1 by 3, okay. So here m equal to minus 2 by 3 and b equal to minus 1 by 3. So you can see here at this point is represented by minus 1 by 3. So this line is cutting on the y-axis at point minus 1 by 3. And now if you want to see how this works, slope minus 2 by 3. So here you can also write it as delta y upon delta x. Okay, so my delta y is minus 2, that is my rise, and my delta x is 3. So if you want to explore here how this works, okay, so just a moment. Yeah, so let's start from this point. Okay, so we are going in a horizontal direction. There is change in x is by unit 3. Okay, so let me count it. 1, this is 1, this is 2, this is 3. Okay, so my change in x is 3. Okay, and my change in y, okay, and it is a minus 2. So what minus represents? Means minus represents you are going in downward direction by unit 2. So 1, 2. Okay, so this is my minus 2 and this is my 3. So my slope is defined by minus 2 by 3. So from these things that we study by using the different equations on the graph, by plotting the different lines, so I think that you have got a better idea how slope and intercept works. Okay, now just revisit the previous revisit the types of slope that we have studied so far. Okay, so if you can see here from this picture, if the line is coming in the downward direction, okay, so it is called a negative slope. So the value will be always negative for the slope. And if you can see here, line is going on the upward direction, then the value of slope will be positive. And if you see here, the zero slope, okay, so on the zero slope, the y-axis, okay, y-axis will be constant. Okay, there will not be any change on the y-axis, only there is a change on the x-axis, that is delta x. So this is called the zero slope because the change in y, delta y, equal to 0. Okay, and delta x can have any value, so it is like 0. Okay, so it will be 0. And for vertical straight line, so you can see here the delta y changes, but the delta x, that is x is a constant, so there is no change in the x, so delta x is 0. So something upon 0 is infinity, but we cannot define it as an infinite slope, so we are saying it as a no slope. Okay, and one last thing that I want to explain you is this equation is called a slope intercept form, as I have told you earlier. Okay, but there is a another normal equation of the line which is written as ax plus by plus c equal to 0. Okay, so let me pick any equation, okay, that we have studied so far. So I am writing this slope intercept equation y equal to 3. Now let me convert it into the normal equation. Okay, so I can write it as a 0x plus y minus 3 equal to 0. So if you convert this equation, so this will be converted into this slope intercept form, but this is the equation, this is a normal equation of the line in the 2D space. Okay, and if you want to see how this equation is written in the 3D space, so it is written as the same, and only the third variable is added. It is represented by ax plus by plus cz, okay, equal to 0. Sorry, here there will be a constant cz plus d equal to 0. Okay, yeah, that's it.